When you hear AI agent, what comes to your mind? A chatbot, coding agent like Claude Code, Codex, or Cursor, or an autonomous agent that does digital tasks for you? Actually, all of them are correct. Now, let us see what an agent actually does under the hood. Here is what you will get in the next few minutes. First, clear definition of an AI agent. Second, a real business example, not an usual booking a flight or YouTube video research agent, but how I actually used two agents in our application security program. And the third, when to reach out for an agent instead of writing program. By the end, you should be able to look at a problem at your own work and make a decision whether an agent is the right fit for the problem you want to solve. Now, an agent is an autonomous software system that uses large language model LLM, which is the AI part of an AI agent, to perceive its environment, use tools, make decisions, and take independent actions to achieve a specific goal. You establish a goal, you give the agent an LLM and give it the necessary tools and permissions to use them, and you let it repeat the process until it achieves the goal. The main components of any AI agent are LLM, which is the brain for the reasoning and decision making. It can be Claude or GPT or Gemini and many more open weight LLMs. The tools, external tools that are existing reliable programs, internal and external APIs, MCP servers, skills, and even databases. You want to give autonomy to an agent by setting up action and reflection loops to reach the goal. Agentic approach is not deterministic like a software program. It is actually probabilistic, but with right guardrails and AI harness, you can make it almost deterministic. We will go in depth with those topics in upcoming sessions. An agent harness is the execution framework that integrates LLMs, tools, MCP servers, and specialized skills while enforcing guardrails, memory management, response verification, and continuous logging and monitoring, which is part of observability. Now, let us look at a real-world example with enterprise business use case. The way I used AI agents involved two of them: a collector agent, let us call it Colleen, and a research agent, Ray. Agent Colleen's job is to collect vulnerabilities from different sources like application security, code and component scanners, SAST, SCA, IAST, and DAST tools, and also from detection tools like Wiz.io, CrowdStrike, Zscaler, and logs from GitHub Access, logs, server logs, and few other sources. Colleen's job is to prioritize the data with the highest value, normalize it, store it in a standard format like serif and JSON. At this point, you might be thinking this can be done programmatically, right? Yes, but a lot of this data is unstructured and unpredictable. The unstructured data is from reports like PDF, Word reports, from sources where we don't have API access, and also screenshots, detailed diagrams. The unpredictable data is when sources might change and formats are not well defined. Unlike traditional programmatic approaches that throw exceptions when encountered with unpredictable changes or unstructured data, AI can dynamically adapt, analyze the failure, and self-correct to find a workaround. The research agent Ray ingests the large-scale normalized data sets processed by Colleen, conduct advanced threat analysis, utilizing specialized skills and integrated external threat intelligence such as VirusTotal, Gray Noise, GitHub Advisory Database, and CISA KEV, known exploitable vulnerabilities. Ray validates suspicious SHA-256 hashes, malicious IPs, and compromised websites. The agent performs timestamp-based event correlation across multiple sources, blending this telemetry with internal corporate context like applications, products, and tech stack. To execute this threat modeling, ultimately Ray delivers a prioritized security report mapped by risk and impact designed to hand off actionable actionable insights to the security team or for a future automatic response agent. Through iterative fine-tuning and enhanced correlation capabilities, the agent now delivers highly accurate results. By filtering out low-impact background noise across multiple tools, we can immediately target high likelihood, high severity vulnerabilities. This approach builds proactive layers of defense and reduces real-world risk by securing our most critical assets first. So, why did we build an agent instead of just writing a regular program? Well, we touched on it a bit earlier. A traditional program is great at handling structured, expected data. Think JSON or XML. But the second you throw unexpected data at it, it breaks. If you give it a screenshot, it fails because it does not know how to spin up OCR on its own. But with an agent, you get a massive reasoning advantage. If you mix a raw server logs together with a threat intelligence data, the agent can actually think through it and differentiate a basic log from a real vulnerability. That ability to reason is the exact edge an AI agent has over a rigid programmatic approach. So in this session, we covered three major things. First, we defined what an AI agent actually is. It's an autonomous system that uses an LLM for its reasoning engine, hooked up to internal and external tools, MCP servers, and custom skills to take independent action towards a goal. Second, we looked at real-world use case, our two agents, a collector and a researcher, working together to turn messy, chaotic security data into a highly prioritized actionable report. And third, we went over when you should actually deploy an agent. The big indicators are when you are dealing with massive sets of unorganized, unstructured, or totally unexpected data. And the fix requires continuous loops of reasoning and iteration that a traditional programmatic approach can't give you. So here is your first step. I want you to think of just one data-heavy problem in your own domain right now and sketch it out using this simple formula. Goal plus planning plus LLM plus tools. That is your first agent. We'll see you in the next one. Thank you.